Here is another interesting problem that I found on RIT website, and it could be used for AP Calculus or Calculus students. And I find it interesting because the shape that is made by these curves is usually not a usual one. So find the area of the region enclosed by the following curves: y is equal to x squared, y is equal to x plus 6. And then you have them defined by two x lines, which is x equals to 0 and x equals to 5. So at first, as usually, we have to sketch the graph, and let's look at what the graph would look like. So here is the graph made by the curves that they represent. And in this case, it is very important to draw the graph since the function intersect between the boundaries. This means that it will have to actually calculate two separate integrals, because at first one function is above the other and then they switch which one is on top, which one is at the bottom. So for that we will need to know the points of intercept. So we will have to calculate from at first between x equals 0 to the point where we find there's going to be one integral, and then from that point to the point where they intercept again. So we need to know 2 points that are important for these calculations where the graphs they will intercept. So I have to set up two y's equal to each other to find the points of interception. I have x squared is equal to x plus 6. If I do my calculations, I find the first point where the graphs intercept, and that is going to be 3. And the second point is -2, where they intercept. So this one is going to be -2. But we only have to look at these two areas. So one is right here, and the second one is this area. So we will calculate two different integrals, one between 0 and 3 and the other one between 3 and 5. For integral between 0 and 3, I'm going to have the integral between 0 and 3, and I will have x plus 6 is the top function dx, and the bottom function is x squared. And that's going to be minus between 0 and 3 x squared dx. And for the second function, maybe I'm going to make it in green. So for the second function right here, I'm going to have the integral. The top function in this case is x squared. So it's between 3 and 5. And then I have x squared dx minus the integral between 3 and 5 of x plus 6 dx. Then I will have to add my two results, and that will be the total area underneath the given curves. So if I take the integral of both, I will have 1/2 x squared plus 6x, and then the second integral will give me 1/3 of x to the third. Now if I plug in my values for 0 and 3, I will have 13.5. So this is for the yellow area, and then for the green area, again, I'm going to take the integral of both integrals, and the intervals are 3 and 5. And now if I plug in this, I'm going to have that I will get -0.83 plus 13.5, which gives me 12.667. Now I have to add these two results that I got together, so 13.5 and 12.667. So that will give me 26.167. So the total area underneath these two curves, the shaded areas, would be equal to 26.167.